All right, folks, we are on to the last video lecture of our series, and after this, you'll be done with your semester. Now, just before I start this final topic, I just wanted to make a request to everyone. Soon you will be getting the feedback forms. How was your experience with this in the semester with your teacher? So I will, first of all, I'll request everyone to fill that form and do write the comments, because in past what has happened, only those students who didn't had a good experience with me, they end up doing the review, and it just doesn't give a fair reflection how I've done. And my request to you guys is to try and look into certain good things which I might have done for you guys. For example, all these video lectures which I am posting, these are not mandatory for me to post as a part of my as a part of this online asynchronous course. I'm just posting it so that I can make your experience better. So if I might have missed answering your email accidentally, certain times students get really grumpy, and then they say that, oh, he doesn't answer our emails. And as I told you in my first video lecture also, it's not intentional. Sometimes I get busy, and then I it just gets out of my brain. So as I said, look into the positives also, and I will request everyone to do the review. All right. Now, before wasting too much time, I will jump into the final topic of the day. That is fission, and fusion. All right, so fusion, first of all, I'll talk about fusion. What happens in fusion? So remember chapter 16.1, what happens in that? So there were four hydrogen atoms. They came together and they were moving at the speed of light, and they formed a new nucleus. A new nucleus of helium was formed. And once this new nucleus was formed, there was a loss of mass, and that mass was converted in the form of energy, and energy was equal to mc square delta m. Whatever the mass lost was, that got converted into energy, and that whole process is called fusion process. Now let's talk about fission. In fission, a bigger nucleus gets broken into smaller nucleus. So for example, if this is uranium, it gets broken into krypton and barium, and some neutrons are released too. Some neutrons are released too. So this process of breaking a bigger nucleus into smaller nucleus and the release of energy is called fission process. This is a fission process. So hopefully you were able to understand the difference between these two. Now let's look into an example for the nuclear fission process. From this chapter, chapter 13 of 16.4, my expectation from you guys is to do at least page number 819. Try and do those examples. All right, I'm going to take an example, as I said, from chapter 16.4. Example is 16.14. Now in this, we are given calculate the energy released in the fission reaction. We are given that uranium-235 92 gets broken into smaller elements, and those are barium. 144 is the atomic mass number, and atomic number is 56 for barium, plus krypton, which is 92, is atomic mass number, and 36 is the atomic number. So please make sure, before I start solving this question, I just want to tell you, remember the difference between atomic number and atomic mass number, number of nucleons, number of protons, number of neutrons. What is the difference between neutron and nucleon? What is the difference between proton and neutron? So please make sure you remember all these terminologies which are from chapter 16.1. Okay, and there is, coming back to the topics, there is a release of 3 neutrons in this. So this is an equation given to me that uranium 235 undergoes a fission reaction. Fission reaction means a bigger nuclei is breaking into smaller nuclei. Okay, and 2 new nuclei are formed, barium and krypton, and 3 neutrons are released in this process. And I wanted to calculate how much energy is released during this process. All right, my computer screen got stuck. Hopefully it will start working again soon. I'll try to squeeze in whatever I can write in here. So in this one, first of all, we will try and calculate the mass, total mass of the given elements, parent elements, and then we will try to calculate the total mass of the daughter elements and then subtract those two. So if I look into the end of the book, and that is on page number, let me quickly check it for you guys. So it's given to you on page number 881. 881. In exam, if I ask a question like this, you will be provided all this information. You don't need to go memorize this, or you don't need to open the book to know about these numbers. All right, so this is an element given to you, and for this element, the atomic, well, you are given the atomic mass is 235.043930, and for neutron it is given to you 1.008665. You add these two, that's going to come out to be 236.0525595. That is the atomic mass of the parent elements. Same way you're going to calculate for the daughter elements. So look at the end of the book, and on, as I said, page 881, you will be able to find for barium, krypton, and for the neutrons, you make sure you multiply neutron by 3, because there are 3 neutrons which are released, and you're going to get the number as 235.866563 as a total mass of these 3 elements. And now you will find the delta M, which will be the subtraction of this from this. That's going to come out to be 0.186032. And then you will convert it into the energy form. Delta E is equal to 0.186032 multiplied by 931.5, and that will give you total energy in terms of MeV, 173.3 mega electron volt. From where I got this number? This number is given to you in the book in chapter number 16.1. You can note down this number also on your formula booklet too. So I think if I go back, let me just quickly go back and check what this number exactly is about. So energy correspond to 1 U, 1 atomic mass unit. E equal to 931.949494 MeV correspond to 1 U. That much energy is released when 1 U is lost. All right, so hopefully you were able to understand how to simplify this question. So I'll recommend you to do some questions from page 819, and from chapter number 16.2, what you need to do is, my expectation from you guys is to at least know what is radioactive decay, or alpha decay, sorry, alpha decay, beta decay, and gamma decay, which are a part of radioactive decay. So radio, let me change the color of my pencil from chapter 16.2, radioactive decay. What are the three types of decay? Alpha decay, beta decay, and gamma decay. What happens in alpha decay? Mainly helium comes out of an element, helium. So if this is uranium, which undergoes a alpha decay, means it will convert into a new element and helium will be released. So alpha means helium particle. So 2 4. And under beta decay, there are two types of decay: beta positive, beta negative. Please make sure you understand the difference between two and look into the book, it is given to you. And gamma decay, only energy is released, only energy is released. All right, so that was that's what I will request you guys to know from this chapter. And you must know page, you must do the questions from page 799 and page 800 at least. This is a minimum expectations from chapter 16.2. So hopefully you were able to understand the last video lecture, and I wish you all the best for your future endeavors. I thoroughly enjoyed teaching you guys, especially some of the students are sticking with me from I guess from physics 181, and that everything comes to an end, and your physics is coming to an end also now. I wish you great luck for your future endeavors to everyone. And yeah, please don't, make sure you don't forget to do the review and leave a comment also. Bye now.